All right, this is section 5.2, worksheet 2. Everybody has it? Okay, today we're doing verifying identities, not just simplifying, okay? This is like proofs in geometry. You have to show your steps. Lucky for us, I'm not going to make you say the reason all the way along, okay? Like you had to do in geometry, okay? But you do have to work with one side only. To verify an identity, you have to prove that both sides are equal by working with one side of the identity to get it to equal to the expression on the other side. You cannot work with both sides. That also means you cannot cross multiply and divide. Okay? You can only work with one side, and I need to be able to follow clearly all of your steps. So you can't skip steps like in advanced classes. Sometimes in college they'll let you say, it's clear that this goes to this just because you know it. Well, that's not going to happen here. You need to show me all the steps. All right, I don't know why this is not opening the copy that's not written on. All right, well, we'll fix this. All right, so this is how it started. And they decided to work with the left-hand side because it's the more complicated one. They want to get it to say sign equals. So this is the first one that sometimes would stump students. What did they do there? What did they use? Yes, one of those Pythagorean identities, okay? And I will allow you to use one of those trades for a Pythagorean identity without writing a whole bunch of explanation, okay? You can just substitute it in. Then they traded tangent for sine squared over cosine, or tangent squared is sine squared over cosine squared. Secant squared is 1 over cosine squared. Then they said when you divide, you really multiply by the reciprocal, so they flipped this guy over. Then the cosine squareds canceled and they just had sine squared. I know in some teachers' classes they have you write this. Anybody know what that even stands for? It says the sine squared, okay, sine squared of x is equal to the right-hand side up here. Just stands for right-hand side because you got the left-hand side to equal the right-hand side from up here. You don't have to write that for me. I kind of like the book's idea of putting your little check mark here, see how they did, to show that you got it equal to the other one, okay? Then you don't have to rewrite anything. I used to make students say therefore, like a formal proof, and then rewrite this whole statement. I have now shown this side equal to this side. Yeah, I'm not all about being picky anymore. All right, I don't know why the ink is on all these pages, but we're faking it our way through here. Okay, secant. Which side, first of all, do you think we should start with? The issue if we start with the multiplication side is, what are we going to trade for to get it to subtraction? If we start with the subtraction, we maybe could get a common denominator and get it down to something that didn't have a subtraction anymore. That sounded like a better plan to me. So if we start over here, what will we trade this side for? And guys, I've said this before, but if you forget your thetas or your x's and you just write 1 over cosine minus cosine, it's not the end of the world to me. It's not proper notation, but if you check my answer key, I'm pretty sure as I was flying through, I forgot all those little thetas and x's until the end of the problem. So, all right, now what? Can't do anything. Can't cancel anything because it's not multiplication. Common denominator would be? So this one needs to be multiplied by cosine over cosine. So we will now have, now I'm going to talk about this. We have this step, and then we're going to combine into a single fraction. I will tell you it's okay to skip one of those steps. Skip the first step here. This is optional, rewriting it and then combining it. If you want to go straight from here to here, I'm okay with that. Does everybody see what I'm saying? That seems pretty clear to me that you could. So this step, I would consider showing that to be optional. Right, then what? Why? Okay, if we can't multiply, we can't randomly multiply by just a cosine. We could multiply by this because it was equivalent to 1. Or if we're multiplying on both sides, we could randomly multiply by a cosine. But we can't work with both sides when we're doing verify, though. Okay, so we need to do a trade. 1 minus cosine squared is a sine squared. So now we have sine squared over cosine. Any ideas? Okay, but it's supposed to be sine times tangent. This one's squared, isn't it, guys? So we have a sine and a sine over cosine, which is a tangent. So we really do have sine times tangent, which is what they wanted, way back up at the top, right there. So to check, left-hand side equals right-hand side, whatever you want to write. We good? Anybody stuck? Further math classes. Yeah, there's not a good answer to that question. Except, let me say, yeah. This is used, there's a lot of trading to be able to do. Remember I think I did an example yesterday where I said, remember how messy it was? You didn't, when you simplified it down, then you could take a derivative in calculus or something, okay? So that's the reason for the trades. This actual verifying and proving things, I did in like advanced calculus, which was like the 5th class, which I'm pretty sure I barely passed. I don't know, but yeah, it's a long time ago. I was salutatorian, but.
Did you pass a advanced?
2nd.
Calculus class now?
Only in high school at North Boone, really. That's not anything to brag about.
Could you pass an advanced calculus class now?
No, I probably couldn't pass Calc 1 without taking the class. All right, guys, help me out here. I'm thinking we should work with that mess to try to simplify it down to this, okay? Do you want to distribute first or change things to sines and cosines first? I don't think there's a right or wrong answer.
Sines and cosines first.
Okay? I'll go with veggie this time. It doesn't matter. Now you need to distribute, though. What is sine times sine over cosine going to become? Sine squared over cosine, we good? And what about sine times cosine over sine? That would just be a cosine, right? The sines would cancel. You could write it as sine cosine over sine, but then you got to get a common denominator and everything. We're going to need a common denominator anyway, but right now there's only one denominator to worry about. That seems better. Now what? This guy's got to be multiplied by cosine over cosine. Good job. So we end up with a sine squared. Yep, I heard it. Cosine times cosine is cosine squared, so that mess is going to become what? 1 over cosine, which is secant. But please show this step so it's clear how you got that 1, okay? That's a Pythagorean identity, right? Sine squared plus cosine squared equals 1. Everybody's okay with where we got that? I just pull it out of thin air. If there's a lot on the back. We will eventually do half angle, double angles, and this looks really confusing, but the only thing I'm worried about is this little tiny chart right up here. Okay, that's where I'm going to find the majority of my trades. All right. Oh, try this one, guys, on your own.
You go with the 1 first.
One like that on the quiz would be okay?
Oh, yeah.
It's all multiplication, so anything on the top can cancel with anything on the bottom, and I think it does all cancel, right? So we get 1.
That was so hard. I mean, I don't know.
Max got that one? We're good? Excellent. You okay, or want me to go back over it? You got it. Excellent. I thought you could get that one. All right, what are we doing here, guys? Yeah, we definitely want to work with the left-hand side. This is a question I'm going to show you a little trick. Because we're going to have a fraction over a fraction plus a fraction here. If we change this all to sines and cosines. I want to review real quick. Do you remember ever, and there's a chance that you don't remember this, do you remember doing anything like that?
Nope. No.
Okay, these are complex fractions. These show up in Calc a lot. And what you want to do on something like this, rather than try to, you can't flip the denominator over until you get it to be a single fraction. Okay? But there's a trick. If you multiply the common denominator for all of these fractions by the top and the bottom, you'll have a little magic. What's the common denominator for all of those fractions? X times x plus 1, right? Common denominator has to have all the factors. Okay, look what happens when I multiply this. Remember, it multiplies to the top, right? So the x plus 1 will cancel, and I'll just get x. Down here, I have to distribute it to both of those. When I multiply it over here, the x will cancel, and I'll just have 1 times. When I multiply it to this fraction, the x plus 1s will cancel, and I just get, wow, no complex fractions. Now can I cancel the x?
No.
Thank you.
Meow.
All right. But was that a pretty nice way to handle that problem? Okay. I wanted to show you that because I want to talk about how we can get rid of all of these fractions. Whoa, what am I doing? Wrong way. Come on. All right. Cosecant is what, guys? 1 over sine. Cotangent is I'm going to go with cosine over sine. Ooh. Plus, tangent is
1 over cotangent.
or sine over cosine. Okay, I changed. Remember, that's like the first hint on your sheet of notes yesterday. Change everything to sines and cosines. Okay. Now we're going to use my hint to get rid of the fact that we have fractions and fractions and fractions, okay? What's the common denominator? Be careful for everything. sine times cosine. And that's kosher because it's okay to do something the same to the top and the bottom, right? Anything I want. If I want to put a 6 on the top and multiply 6 through on the top and the bottom, I can. I don't think it'll help, but I could. All right, up top. 1 over sine times cosine. Right, the sines cancel. 1 times cosine is just cosine. All right, on the bottom, this has to distribute to both of these, the whole thing. Okay, cosine over sine times cosine. Cosine squared. I'll write it over here if you need me to. Cosine over sine times cosine. These sines cancel and I get a cosine squared. Are we good? Sam, you may be a step ahead of me already. I don't know. Yeah. But now when we multiply this, we get sine over cosine times cosine. This time the cosine will cancel and I get what? Evan? Did you have a question? Okay, I'm sorry. I thought you had a question. Okay, just keep that in mind when you have a whole bunch of fractions and a mess. All right. Here we go. 1 over sine minus 1 minus 1 over sine plus 1. They love to throw these on there all the time. We have to multiply to get a what? Common denominator. What do we have to multiply this one by? This one gets a sine plus 1. So it becomes sine plus 1 times 1 or just sine plus 1. This one has to multiply by a sine minus 1. Be careful though. What are we multiplying that by? Yes, this is a negative 1. So when I distribute that through here, I get a minus sign and a plus 1. Everybody okay with that? Negative 1 times sine, negative 1 times negative 1 is plus 1. Okay, what happens in the denominator if I FOIL those together? Sine plus 1, sine minus 1. Yes? Sine plus 1 times sine minus 1. Sine squared minus a sine plus a sine minus 1. Sine squared minus 1. We good? Okay. Is this going anywhere good?
No.
It is.
No, let's just leave it and go forward.
What can we do?
Yeah.
So what do we end up with up top? We're not multiplying, we're adding and subtracting. So a sine minus sine is 0, but a 1 plus a 1 is 2, which seems like a great idea because there's a 2 in the answer, right? Okay, sine squared minus 1. If sine squared plus cosine squared equals 1, if I subtract this way and subtract that way, I'll have sine squared minus 1 equals what? And you don't have to show all that over there. I'm fine. You can not show that, and you can not show this, and I'm going to assume you knew what you were doing. It's a big assumption, but okay. This says I'm supposed to have a -2 times a secant. Well, if I take a -2 out of that, I have a 1 over cosine squared. Is that a secant? It's a secant squared anyway, right? Yes.
That's like a 7 times 6 big.
Are we good? Okay, number 6. Now, earlier today they asked me why can't we work with this side? And we can if you remember this. Do you remember factoring this? That's supposed to be a v. Factors u minus v times u squared plus u times v plus v squared. Okay. That's fine. I'm good with not doing that. So we want to work with this side? This is a problem that I probably would not put on a test or quiz, honestly. Okay, FOIL this for me. FOIL this right-hand side. 1 times sine is?
Sine. Theta.
1 times negative cosine?
Negative cosine. X.
Sine x cosine x times sine x?
Sine x squared plus cosine sine.
Okay, one more time. All of this multiplied together becomes?
Oh, sine x squared or sine squared x plus cosine.
No plus, right. All right, now what? We got to do this term times this. So we get a negative cosine squared times sine. Or sine times cosine squared. Doesn't matter what order you wrote it in, it's multiplication. Okay, at this point, most of us are stuck and don't know what to do. But what are we looking for? Remember on the little yellow sheet, it always said, look ahead. I need a cubed. Nothing's looking like a cubed yet, right? So this was my idea, and that's why I say I'm not sure I'd put this, pretty sure I wouldn't put this on a quiz. But I can trade that for a what? A 1 minus cosine squared, because then when I distribute through that other cosine, will I get my cosine cubed? I'll even get a negative cosine cubed. Does that seem like a good plan? Okay. So out front I had a sine x, then I had a minus cosine x, and I'm trading my sine squared for a 1 minus cosine squared. It's still being multiplied by that. What about back here? I'm thinking I kind of need to do the same thing. What do I need to trade that for? I'm gonna switch the order on these two. I'm gonna put my sine x out in front, and then back here when I trade that, it's gonna be a 1 minus sine squared. Okay, sorry, that's really messy and off the edge of the page. All right, can't do anything with this. Sine x minus cosine x. Can you distribute back here though? To ISS? Is that where you want this? Laplace? You want to stay for the Laplace? When I distribute, I get cosine x minus what? Cosine cubed. Back here when I distribute this, what do I get? Okay. There's no longer any multiplication. So a negative cosine plus a cosine and a sine plus a negative sine. What do I have left?
Sine cube x minus cosine cube. Holy nutcracker. It works.
There's my big check mark. We get a big check mark because we're proud of ourselves for that one, right?
We should have star.
That looks
Like a
like a
yellow star.
satanic star. Not in my school, Mrs.
A yellow one.
It's everywhere.
Give me 3 more.
All right, let's keep going, or we're not going to have any time to get to questions today, and that was my goal. Tangent is sine over cosine plus cosine times 1 plus sine. Common denominator. So this needs to multiply by a 1 plus sine. Well, this one is being multiplied by what? I do have to distribute this, so I get and when I multiply these together, now the denominator has a cosine and a 1 plus sine. And honestly, I probably would have multiplied that together, but eventually if we want to cancel some stuff, we're going to have to factor it back out. So I'm telling you, we should just leave it cosine times 1 plus sine. Because what happens up top? Sine squared plus cosine squared is a 1. And then something's going to cancel, but please rewrite it because you can't cancel as long as there's adding and subtracting going on. A sine plus 1, that whole thing will cancel with this sine plus 1 that's down here, right? Or 1 plus sine, same difference. Is the answer cosine? 1 over cosine, which is okay, got a little carried away there. I want to make a big check, but I just made a big mess. There we go. There's my big check mark. If you just want to watch one and not write it down, I don't know what to tell you. What's common denominator going to be? So this guy needs to multiply by a... So I will get a sine squared all over a sine. Sorry. Times a 1 plus cosine. Over here, this one needs to multiply by what? Okay, we need to do a little foiling up there. 1 times 1 is 1. 1 times cosine plus another 1 times cosine is... Everybody okay with where I got that? Inside, outside? Okay. Cosine times cosine is... Ideas? Can we cancel out what? Yep. We can only cancel if we have a quantity. You can't cancel any. This is all right now being added together. Can't cancel any of it. But can we rearrange the order? What's a sine squared plus a cosine squared? So that can be replaced with a 1. Then we have 1 plus 2 cosine, which would be 2 plus 2 cosine. Factor out a 2. We're just going to let Journey take this quiz for all of us. You can clearly see that. Not. 2 over sine is the same as 2 times 1 over sine, which is the same as 2 cosecant. And honestly, if you went from 2 over sine to 2 cosecant with right now, without that middle step, that's fine. No. All right. Please, we need to finish talking about this because this is calculator stuff. There are 3 of these assigned on the homework. It says graph to determine if this is an identity. All right, I need to teach you something about your calculator. I think we've done this once before, but just in case. What we're going to do is we're going to graph, and I'm going to cheat. And in Y1, we're trying to graph cosecant minus sine. So we're going to do 1 over sine for the cosecant, right? And then minus sine. In Y2, we're supposed to graph cotangent times cosine. Cotangent, you could actually put cosine over sine there. Okay. Otherwise, you can just do 1 over tangent for cotangent and then times cosine. All right, going to type this in your calculator. You need to be in radian mode. Go to y equals. In Y1, we're going to type 1 divided by sine x minus sine x. And you could put an extra parenthesis around the 1 divided by sine x if it made you feel better, but it'll do order of operations. It would always divide before it's subtracted, so you don't actually need it. This is a multiplication. I don't know, again, you could get by without this parenthesis, but it's 1 divided by tangent times cosine. All right, again, I'm in radian mode. This is the trick. We're going to graph these all in the same window, and we want to check that they match, that they're the same thing. So, you're not going to be able on your calculator, unless it's a color version, to see whether they are the same thing. So here's my suggestion. Go down to Y2 and arrow to the left until you're out front. And then you can make that a bold line by hitting enter once. So it's going to graph the first one, Y1, in a nice narrow little line. And then it's going to come back through and graph Y2 in a bold line, and you should be able to see if it's going over exactly the same spots. Now, if you haven't been in this graphing mode for a little while, go ahead and do a zoom trig, unless you already had an appropriate window. There's the first one, Y1, and now here's Y2. Okay, is it going right over exactly the same spots? And all the same spots. There's one on the homework where it's really hard to tell because it has a couple holes where it's undefined. Yeah, it's a little tricky, but this one's going right over everything. So are these equivalent? Yes. That's all you have to do. The book says now prove it by verifying the identity. I'm going to say skip that because I've assigned enough other proof problems. Does that sound like a plan? All right, let's try this one. Type these in. Did everybody get that bold thing to work? Anybody need help? Sine plus cosine times cotangent, or sine plus cosine times 1 over sine. And then cosecant is just 1 over sine, and I'm going to go ahead and turn that bold on for the second one. The other thing, is anybody's trying to graph them both at the same time so you can't really see what's happening? There is a mode down here that says sequential or simultaneous. You want to be in sequential so that it graphs y1 first, and then it comes back and graphs y2. If it does them simultaneously, you're not going to know whether they're the same. You need to be in radians and do a zoom trig. If it's still not working, let me know. It's going over the same stuff. We okay? So we have another yes. No? Oh. Go to y equals. Yours is a color? Yes, you could just do on the color. It's nice. You don't have to do anything because it'll automatically do it in a different color. So you'll be able to see it change color if it's the same. Yep. Color is really nice for this because if you do the first one in blue, the second one is red, it'll graph it as blue, and then as it goes over the top, it'll graph it as red, and it'll change color. All right, one more. This is the one I was most worried about, because we haven't talked about a lot of this, but cosine squared, you have to do the whole cosine and then square it. Okay, so try typing that one in. Anybody have a guess whether this one's going to work? Why do you think it's not? Sine squared is equal to what? 1 minus cosine squared, right? So not 2, so I think you're right, it's not going to work. Well, let's see what it looks like, because that's always great fun. Two minus cosine. And I think I learned that you could cheat and just put the squared outside of the x and it'll work. It's really bad notation, but I think the calculator will let you get away with that. We'll see. Does mine look like yours? Oh, I forgot to turn the bold on, but is it, you getting 2 separate lines? Okay. So this one is just no, and even if I told you you had to do the proof, this one would still just be no, because you can't prove that they're not equal. All right, so the assignment on this is here, and guys, the reason this looks all messy, like why didn't you just assign 1 through 15, or I went through and tried to pick out the ones that were really horrible and nasty and I had trouble with and just got rid of them, okay? So, yeah, I picked those. No. So this should be doable, I'm hoping. And the last 3, 34, 35, and 36, you just need to use your calculator like we just did and decide, does it an identity or not. Did anybody work on last night's or worksheet 23 or 24 and have questions? Let me turn the recording off.